In 2004, NASA unveiled the Hubble Super Deep Field, a stunning image captured in a small part of the Fernax constellation. There are about 10,000 galaxies in this image, showing the past. Some of these galaxies formed 13 billion years ago, just 800 million years after the explosion known as the Big Bang. These images of the universe provided an important opportunity for scientists to study galaxies at different stages of their development. To illustrate this, let's consider a group of strangers who are curious about the nature of human aging. Fascinated by their saucer-shaped spacecraft, they decided to take photos of all the people gathered in New York City's busy Times Square. By taking comprehensive images of people of all ages, these aliens can perform further analysis and gain more insight. Also, astronomers use the Hubble Ultra Deep Field image to track the evolution of galaxies. And no matter how many new detectors we have, astronomers still struggle with many unanswered questions about the true formation and evolution of galaxies. We also know that some of the oldest galaxies formed when the universe was about 1 billion years old. However, the advent of the James Webb Space Telescope, JWST, expanded our knowledge and revealed the existence of galaxies when the universe was only 300 million years old. But when it comes to determining the evolutionary sequence of the world's largest celestial bodies, scientists face a dilemma similar to the age-old question of which came first, the chicken or the egg. Determining whether galaxies and black holes first formed is a major mission of NASA's James Webb Space Telescope. Explaining this is the observation of a large structure that has fascinated astronomers since 2013. During that year, astronomers made an amazing discovery using data from at the Herschel Space Observatory. They stumbled upon the first known galaxy. However, this discovery came with an interesting twist. This device, called HFLS-3, showed remarkable properties. Although the universe is only 850 million years old, HFLS-3 bursts with many new stars, challenging theories of rapid galaxy growth. Although they have the same mass, this galaxy is about 2,000 times faster than our own Milky Way galaxy. As the universe raced, astronomers predicted that galaxies would not grow large or exhibit very high birth rates. This discovery challenged the accepted theories and raised questions about the understanding of galaxy evolution. Astronomers have suggested that HFLS-3 is not a star-forming galaxy, but an interacting system of galaxies in the early universe. These galaxies are still very bright and full of stars, but they are systems that do not have a single source. With this theory in mind, scientists will convert JWST to the HFLS-3 bright field in September 2022. A team from the University of Oxford created images that show light at different wavelengths and points of view. They analyze the motions and heating of the galaxy's winds and model how much of the halo's focus affects light. In doing so, they also created a more accurate picture of HFLS-3. They expected to see the rotational motion of the gas seen in early galaxies. But instead of one rotating galaxy, they found 6 smaller galaxies sitting close to each other. Based on the intensity of the field, scientists predict that the sextuple system will collide, triggering a wave of new star formation. These new observations are part of a JWST project called Galaxy Assembly and NIR-SPEC Integral Field Spectroscopy. The collaboration targeted 40 of the most distant and massive galaxies to identify the smallest galaxies around them. With these observations, we now know that HFLS-3 is very large and full of bright new stars from the larger galactic community. If it's a giant galaxy, scientists have to go back to the drawing board. As one scientist said, "Fortunately, the Webb came to our rescue and saved our planet." However, we still don't know which came first, a black hole or a galaxy. Last year, however, we discovered something surprising when scientists probed the JWST Advanced Deep Extragalactic Survey, JADES, imager, looking for faint galaxies visible in the infrared. They are unpredictable. Some secrets stood out from the rest. The data, while surprising, make it less likely that young galaxies have storms swirling around their centers. Scientists never expected to see these hurricanes, and the data coming in over the next few months will only add to the surprise. So, what is the clearest explanation that astronomers have come up with? Black holes and millions of suns turn clouds of gas into turbulence. Now, finding a black hole in the past is no surprise, as the James Webb Space Telescope was specially designed to find ancient objects. But my goodness, these first black holes met all expectations. Suddenly we ask, where did the first supermassive black holes come from, and which theory of formation best describes them? Growing too fast, or having a large family? Indeed, in an attempt to understand the early universe, astronomers opened Pandora's box, revealing a series of black holes. This could potentially rewrite established theories about stars, galaxies, and the Big Bang itself. That's right. Scientists have discovered the oldest known black hole, more than 13 billion years before the dawn of the universe. Observations from the James Webb Space Telescope show that the telescope is at the heart of the galaxy that we see today, 440 million years after the Big Bang. At about 1 million times the mass of the Sun, it's an amazing size for a baby black hole, which begs the question of how it grew. Now, these observations do not capture a direct image of the black hole, which is unseeable because no light can escape its gravitational grip. Instead, astronomers detected telltale signatures of its accretion disk, the halo of gas and dust that swirls rapidly around the cosmic sinkhole. Previously, it was believed that black holes accumulated mass gradually over almost 13.8 billion years, expanding consistently through mergers and the consumption of stars and other celestial bodies. However, this gradual accumulation theory falls short in explaining the colossal sizes of contemporary supermassive black holes. This recent observation of the galaxy, named GNZ11, pushes the origins of this mystery back to black holes in infancy and suggests that some black holes grew at a tremendous rate in the young universe, far faster than expected. This would overturn the conventional sequence in which galaxies are thought to precede the growth of black holes within them. Instead, primordial black holes would be intricately integrated into the very fabric of the cosmos right from the beginning. Moreover, these super-early cosmic giants could help unlock a puzzle regarding how their gargantuan counterparts, like the supermassive black hole at the center of the Milky Way, grew to become billions of times the mass of the Sun. This year may bring more answers than mysteries, as the James Webb Space Telescope continues to make headlines, not only for its remarkable discoveries of distant galaxies and enigmatic black holes at the far reaches of the universe, but also for something truly extraordinary. Auroras on brown dwarfs. In early 2024, the telescope captured something truly remarkable. We are all familiar with the amazing phenomenon known as the northern and southern lights, or northern lights, caused by the collision of charged particles from the Sun with molecules in the Earth's atmosphere. Usually, these impressive displays are limited to high latitudes, where the Earth's magnetism directs these particles toward the poles. However, auroras have also been observed on other planets in the solar system, including Jupiter, Saturn, and even powerful moons such as Enceladus. In these situations, the light shows are caused by solar particles that bombard these objects. You can prepare for an amazing show. Utilizing NASA's James Webb Space Telescope, astronomers discovered the presence of an aurora around a failed star, scientifically known as a brown dwarf, named WISE J 1935+1947, located over 40 light-years away from Earth. This brown dwarf left scientists perplexed because there were no nearby stars to supply the charged particles necessary to ignite this stunning display. Brown dwarfs, which are larger than gas giant planets but smaller than stars, form from the collapse of gas and dust clouds, similar to how stars are born. Consequently, many brown dwarfs, including WISE J 1935+1947, are often found in isolation. These objects have earned the somewhat unfair moniker failed stars because they lack the necessary mass to sustain the fusion of hydrogen into helium, which powers stars during their main sequence lifespan. The presence of aurora around WISE J 1935+1947 was indicated by infrared and solar radiation observed by the James Webb Space Telescope, especially for methane.